Okay, now onto the new stuff. It's very, very similar to what we just did with elements, except now we're going to do everything with compounds. But the concept is pretty much the same. First, let us find the mass of a compound. Make sure you know how to do that. And then all the math should look really familiar and should make a lot of sense. Okay, for example, here we have magnesium bromide. If we want to know the mass of this compound, we need to count how many of each element we have and total it up. So for example, how many magnesiums are in this compound? We have just one. How many bromines are in this compound? We have 2. Okay, so then you're going to multiply it by its mass. So here, this is magnesium's mass, 24.30. And then bromine's mass is over here, that's 79.9. Okay, so let's transfer all that information here. Magnesium's mass was 24.30. Bromine's mass was 79.90. Now, it wants the total, so you're going to add these up together once you get a number. So 1 times 24.30 plus 2 times 79.90. Hopefully when you do that on your calculator, you get 184.1 grams. Okay, so that means the molar mass is 184.1 grams per mole, right? So, now the next one. Here we have H2SO4. So let's count how many elements we have. We have 2 hydrogens, okay? We have 1 sulfur, and we have 4 oxygens. So we need to multiply it by all of their masses. So hydrogen is here, 1.008. Okay, so times 1.008. Sulfur is over here, 32.06. So I'm going to write 32.06. Then oxygen is over here. It's 16. So 4 times 16, whoops. 4 times 16, and you're going to add all of these up. So you're going to multiply first, add all them up, and what do you guys get? So do it on your calculator. Tappity tap tap tap. Hopefully you get 98.076 grams. So if we want to write it out properly, it would be 98.076 grams per mole. All right, so here, this one's a little tricky because we have a 3 on the outside here, so hopefully we can count this correctly. Okay, so how many galliums do we have? We actually have only 1. Now the 3 transfers to every element in the parentheses. So how many manganese do we have? We have 3. Now be careful here. How many oxygens do we have? So we already have 4. But we have 3 of those 4. So 3 times 4 is 12. Okay, so now let's multiply by their masses. Oops. So gallium is here. So 69.72. So let's write that out. 69.72. Manganese is Mn. Be careful about Mn and other M stuff. So, but manganese is here. 54.94. And then oxygen, we already looked it up, but just in case you forgot already, it's here, 16. Okay, that's a lot of numbers to multiply. So 1 times that, 3 times that, 12 times 16. And you're going to add it all up together to get what number. So hopefully you figure it out first and then double check with me to make sure you're doing it right. 426.54 grams. If we want to write it out properly, it would be 426.54 grams per mole. Okay, perfect. So now we know how to calculate the mass of a compound. Now, remember earlier we did all that practice problems with elements. Now we're doing the same exact thing, except instead of elements, we're going to do compounds. So what do I mean by that? When you have this number, so if you have 5.4 times 10 to the 24 molecules, molecules is the same color as atoms, because atoms went with elements and molecules go with compounds, but they're still blue colored, okay? Then it asks for how many moles, right? So remember, okay, if you remember your map here, then you will be able to figure out where you're going, okay? So let me find our map. Okay, so we're going from molecules to moles. So now, if you look at this map here, then you will see you are going from molecules to moles. You're going from here to here. So remember, instead of atoms, we're now doing compounds, but we still do the same exact steps. How many steps does this take? It only takes one. So remember, the first step you're going to do is always write down the number that's given to you. So 5.4 times 10 to the 24 molecules. I'm going to just write molic, right? And because it only takes one step, I'm only going to draw one fraction. Now your molecules are in blue, so whatever's on top must go on the bottom. So you're going to write molecules, or I'm going to write molic on the bottom, right? Now, when you have the blue color, molecules, what number do we always use? Just like how atoms was blue, what number do we always use? We used Avogadro's number, 6.02 times 10 to the 23. Every fraction must have a green color, right? So think about what's next on your map here. We're going to moles, so perfect. Here we're going to write 1 mole. So this matches our destination, so we are done here. Top is divided by bottom. So remember to use your E button, 5.4 times 10 to the 24, divided by 6.02 times 10 to the 23. This line always means to divide. You should get 8.97. So number, what are your units? Now it is moles. Okay, that's what the question asks for. And what are we talking about? So we're not talking about an element anymore. We're talking about the compound TiO2, titanium 2 oxide. So 3-part answer. Okay, so if you think you understand it, you can try number 2. So you have the option of working it with me, or you can skip and just go straight to the answer. Okay, so here we're given a number, 6.4 moles. So that's the first thing I'm going to write down. And then it wants to know molecules. So if I look on my map here, so let me erase our, let me erase our old map here. And now let's think about where we're going. Moles to molecules. So here, going from moles to molecules. How many steps does that take? Just one. So I'm going to draw one fraction, like this. Now, moles is a green color. Okay, whatever's on top must come to the bottom. So the green is in my fraction. And I'm going to molecules, which is blue. So I'm going to go to the blue color, right? So remember, green is always 1 mole. Blue in this case is molecules, and the number that goes with that is Avogadro's number. All right, so we reached our destination. So remember to multiply all the numbers on top, divide by the bottom. So you calculate it, and hopefully you get this answer. 3.85 times 10 to the 24. Okay, that's my number. My units is molecules of, let's see, H2O. That's the compound of interest. All right, hopefully you got that answer. 3.85 times 10 to the 24 molecules of water. Okay, so let's try something different. Okay, so let's try a different type of example where here you're going to look for the molar mass of magnesium chloride. So you have 1 magnesium and 2 chlorines. So magnesium is over here, chlorine is over there, and you have 2 of them. So when you add it up together, what do you get? Hopefully it was 95.2 grams per mole. Okay, so let's try out these problems. It says how many moles of magnesium chloride, so you're looking for moles, are in 205.4 grams. Every time you have a number, that's the first thing you want to write down. So 205.4 grams. Okay, we know grams is yellow. So we're going from grams to moles. So if we look at our map here, right, we're going from grams to moles. How many steps is that? Just 1. So we're going to draw 1 fraction. Okay, whatever you have on top must come to the bottom. So that's going to be your grams. Here, this is magnesium chloride, which we have already here. So we're going to do 95.2 grams. All right, now think about your map. You are going to moles because every fraction needs some green in it. So you're going to write some green in here, which is 1 mole. Okay, we reached our destination, so we know we're done. So you're going to do top, and then this is divide by your bottom. If you do that on the calculator, hopefully you get 2.16 moles of magnesium chloride. Number, unit, substance. Okay, I would try the next one on your own if you want, or you can follow along with me. You can check your answer. So here we have 2.98 moles, so I'm going to immediately write that down. Okay, what is the mass of our sample? So we're going from moles to mass. So here, if we're looking at our map here, we're now going from moles to mass. If you look at this, this is a one-step problem. Okay, so we only need 1 fraction. Okay, we know that moles is green, so whatever's on top must come to bottom. Every fraction needs a green, so 1 mole. Then we're going to mass, so we're going from green to yellow, grams. So let's go to grams. Okay, we already have this mass because it's the same compound, which is 95.2. And we have reached our destination, so we are done. Top times top, divide by 1 because it's on the bottom here, and hopefully you get 283.70 grams of your compound magnesium chloride. Number, unit, substance. All right, so here we have 85.6 grams. That's a number, so I'm going to go ahead and write it down. 85.6 grams. Okay, and it wants to know how many molecules. Okay, so I want to go from grams to molecules. Think about our map here. I want to go from grams to molecules. How many steps is that going to take? Grams need to go to moles. Moles goes to molecules. That is 2 steps. So I need two fractions. 1, 2. Okay, grams is yellow. Whatever's on top must come to the bottom, so grams is here. This is a different compound, sodium sulfate, Na2SO4. So we need to find the mass of Na2SO4. So here you have sodium, okay, you have sulfur here, okay, SO4, and this is where oxygen is. So 2 sodiums, 1 sulfur, 4 oxygens, add them all up together. What is the mass of Na2SO4? You should have gotten 142.04. Okay? Now, every fraction needs green in it, and the question is, why? Why, Ms. Park? Why do we need green? So if you look at our map, we're going from yellow to green, so we have to do a pit stop here. So we know that this is 1 mole. Whatever's on top must come to the bottom, so 1 mole also comes down here. Now we're going to go from green to what? Blue. We're going from moles to molecules. So I'm going to write where I'm actually going to color first. So I know I need to go from green to blue. This is molecules. Anytime you write molecules, it's Avogadro's number. Okay, so we reached our destination, so we know we can stop here and do the math. Multiply the tops, divide by the bottoms, and hopefully you get 3.63 times 10 to the 23 molecules of what compound? Sodium sulfate. 3-part answer. Perfect. Now, the last thing I need to teach you is this one example where it takes it an extra step. Okay, so it is pretty special. Okay, so pay attention here. It says how many atoms, remember atoms are for elements, right? These are for elements of carbon are found in 34.5 grams of this compound. All right, so a couple of things. There's a number, so we need to immediately write it down. 34.5 grams. Okay, now we're talking about this compound. So we are going from what color to what color? So grams is yellow, and then atoms is blue. Whoops, didn't mean to cross that out there. Atoms are blue. Okay, so if you think about your map, okay, so let me go back a little bit. We're still going from yellow to blue, okay, which is actually, I don't need to erase this, it's the same route here, okay, yellow to green, green to blue. It takes 2 steps to get there, so I'm going to draw 2 fractions. Okay, now, you're going to do the same exact stuff. So yellow's on top, yellow's on bottom. So grams go here. All right, so here's our compound, C6H12O6. So that's a lot of stuff here. C6H12O6, you have carbons, hydrogens, and oxygens. So carbons, hydrogens, oxygens. You got to add them all up together. 6 carbons, 12 hydrogens, 6 oxygens. Hopefully you get a mass of 180.156. Okay, every fraction needs green. Okay, but why? Because we always are going to make a pit stop at moles, right? So when we came here, we're going to make a pit stop at moles. Okay, and then when you have whatever you have on top comes to the bottom. So I'm going to write 1 mole here. Okay, now we have a compound here, so I'm going to write molecules. Okay, I'm going to go from green to blue. When you see molecules, it's Avogadro's number. Okay, so we're going to find the answer to this problem. Okay, top times top and then divide. If it's under this line, you're going to divide. Hopefully you get 1.15 times 10 to the 23 molecules of C6H12O6. Now, you have to realize that we are not done because this is molecules of a compound, but it's asking for atoms of just carbon. So you have to multiply by a specific number. So think about it. What number could this be? This number is how many carbons were in your compound. So this is still a compound. So in C6H12O6, how many carbons do we have? We have 6 atoms of carbon. So you have to take the number that you found and multiply it by however many elements there are in that problem. Okay, so when you start with a compound and you're ending with an element, you have one extra step you have to do. So take the number you just had on your calculator and multiply it by 6. You should get the answer 6.92 times 10 to the 23 atoms of carbon. That's what we wanted to end with because that's what's in the problem. Okay, so this is our final answer. Ooh, I don't want to cover up that 23. Let me try one more time here. Okay, so like that is our final answer. 6.92 times 10 to the 23 atoms of carbon. Okay, an extra step when you're going from, right? So pay attention here. When you're going from a compound to an element, you have one extra step. Okay, so you should be able to try these 3 on your own. So I'm not going to really talk through it. I am going to have you guys work on it, and I'm going to let you pause, work on it, and then when you press play, I'm going to show all my work and all my answers so you can check yourself. Okay, so this is a self-check practice. All right, go ahead and pause and then check your answers. Okay, so all of the answers are here in red boxes. So basically these 3 problems, number 1, 2, and 3, were just like the example that we did earlier, where it all started out with a compound, but it asked for a single element. So it started with P5O7, right? But then it wanted just phosphorus. It started with K2SO4, but it just wanted oxygen. It started with H2O, and it just wanted hydrogen. So hopefully you followed the example above and got the answers in the red boxes. All right. After that, you'll be doing a practice page, okay? And so hopefully you will understand it all, show all your work, and then ask the teacher if you need any help.